American healthcare is in crisis.
We have a path to prevention. It isn't reversing aging. It's just preventing the age-related morbidities of the big three. It's been a fantasy for millennia. There should be a reboot, new standard of care based on intelligent partitioning of risk. 7 years more of health span free of the major three diseases. 7 years? Who wouldn't take 7 years? I hope we'll seize this opportunity because we may never get another one like this for a long time.
So you've written this really exciting book, Super Agers, an evidence-based path to longevity. And I think it's a very timely topic. And I was curious for you to maybe set the stage for why you wanted to write it and how you see it in the context of other books that have been coming out recently as well.
Yeah, there were a few things that came together. We had done a big study we called the Welderly, where we basically found very little in the genomes of people who had gone to the age of 87 on average with never having had an age-related disease. So that was, of course, one thing that was part of it. The second was I got inspired by a patient I saw recently who was 98 and had never been sick, and her name is Lee Rissall, and her relatives had died in their 50s and 60s. Wow. That's her parents, her uncles and aunts. She was the outlier. And say, why? And then there were the books. They came out. I had patients coming to me. They wanted me to write a prescription for apomycin or order a total body MRI. I said, wait, we got to get the story straight. So these three things together were the impetus that why don't I really get deep into this, everything we know today, and then kind of see if I could lay out some blueprints for where we can go.
It's coming into a world where American healthcare is in crisis. I was curious to get your take on where we are now in healthcare in the U.S. and where do you think we could get to?
Yeah, so there is this bifurcation as I see it. You could call it like the grand slam where you get reversing of aging, so you keep people healthier body-wide, and that's where we see all this remarkable investments in companies like Altos and with reprogramming senolytics and a long list. But they're really focused on a monumental task which hasn't been shown in people, but rather in rodents. The other side of this is we made these big strides in the science of aging with all these layers of data that are using the metrics of aging. And why don't we use that to prevent the age-related diseases, cancer, cardiovascular, neurodegenerative? We've never done that in medicine to any appreciable extent. And this is the opportunity because we have a path to preventing disease. It isn't reversing aging. It's just preventing the age-related morbidities of the big three.
I think that's something that a lot of people may not realize is that the big three that you mentioned, cancer, heart disease, and Alzheimer's and dementia, that they're greatly exacerbated by age. And it's interesting because if you ever sort of wanted to have something that could be a cure for multiple diseases, which would be one of the holy grails of medicine, it would be understanding the biology of aging. Where are we now in terms of things that we can use today?
It takes 20 years to get these diseases, with rare exception. Heart disease, almost all cancers, and neurodegenerative, they are incubating for a very long time. They all have a common thread of a defective immune system and inflammation underpinning. They are preventable variably. So cardiovascular, 80 and 90% from lifestyle and related factors, modifiable factors, like your LDL cholesterol, that kind of thing. And cancer and neurodegenerative, just from what we know today with lifestyle factors, we're about half that can be prevented. So we have some knowledge about averting these diseases, but we have a lot more with all these clocks and new layers of data that are really changing the face of all outgrowths of understanding the biology of aging.
So you, in your book, outline the 5 dimensions of health. I was wondering, maybe you could walk us through them.
Yeah, sure. So the first, most important one is AI, because you need that to pull all this other data we're going to talk about together. This moment that is so exciting is because we have multimodal AI, not only large language, but large reasoning models.
Well, especially I think when you're talking about AI, it's all the things people have seen with generative AI and so on, but also just the ability to understand all this data that you're measuring from people.
Yeah, because the other four are such big domains or dimensions. So the omics, it includes not just gene sequence or arrays, but it has all the proteins, all the proteomic panels that we can get, which we never could get before inexpensively. It includes the gut microbiome, metabolome, and certainly epigenome or epigenetics. So the omics are rich. We are now seeing moving towards things like the virtual cell. Then there is, of course, cells that have become a live drug where we can reset the immune system and cure autoimmune diseases like we've never done before.
So could you give examples of that?
Yeah, so in the last couple of years, we've seen unprecedented cures. We never had anything. Lupus, progressive systemic sclerosis, even cases of multiple sclerosis, dermatomyositis. So basically, it's depletion of all the B cells, and when they come back, they have forgotten what they were attacking. Wow. It's amazing.
Yes.
It's really amazing.
And that leads to the autoimmune reaction.
But the bigger lesson is we have learned how to control our immune system, like a rheostat, and we're going to keep getting better and better as we measure our immunome. But when you can do that, when you can, quash an autoimmune disease, or when you're trying to cure a cancer by just whatever it takes to keep bringing up that immune system specific to the tumor, the immune system is fundamental, and that also now is involving cells and vaccines. So vaccines now are capable of cures of pancreatic cancer, kidney cancer with these personalized vaccines using the proteins of the person's tumor.
Yes. And these are in clinical trials right now.
Yeah, it's stuff like we've never seen, you know. And that's just a front runner of what vaccines, that's to treat cancer. We're going to be using vaccines to prevent cancer. Again, as we get older, some of us especially, our immune system is getting senescent and weak, and a vaccine, before there's any cancer, before there's anything else, could prop it up. We also have drugs to modulate our immune system well beyond checkpoint inhibitors. And so, whether it's antibody drug conjugates or tumor infiltrating lymphocytes and all these different ways, it's hard to imagine that in the future we're going to lose people with cancer because of being able to bring their immune system to the highest level when we need it. But more importantly, preventing the cancer. We can do that now. That's what's exciting.
Well, and so if we put all this together, what does this mean for the individual? Like, how would their life change? What should people be doing?
Yeah, so I call it Lifestyle Plus. It's a lot bigger than diet, sleep, and exercise, which, we can drill down on, but it's involving, all the environmental burdens, air pollution, the plastics, microplastics, nanoplastics, and forever chemicals. And then there's other things like time in nature. So if each of us pulled out all the stops for the lifestyle factors, which is a long list, that will help. But it's not going to be only lifestyle factors that are the ways to prevent the big three age-related diseases.
You described a large range of things from the sort of most almost sci-fi-like drugs that are in trials for preventing cancer to lifestyle. I could also imagine AI coming into this, because one of the things AI is very good at is to take a set of data and maybe you can mask out the last bit. So you can maybe have someone's health records over 30 years and train on that, except for the last 5 years, and see if you can predict the last 5 from the first 25. And once it gets really good at that, you can take my records and say, hey, look, Vijay, if you don't do anything, this is where you're going to be. Yeah. And we have 99% confidence on this. That would be pretty chilling.
Yeah. Well, you're exactly right, because the pinpointing here about the timing is so extraordinary. For example, with Alzheimer's, you get a p-tau 217. It's modifiable by lifestyle. You check it again in 6 months or a year. Now you have 2 data points, and you can say, with all the other data that's available, when you're going to see 18 years from now, 12 years, 4 years, mild cognitive impairment, unless these steps are taken. This was fully dependent on AI, on models that can, just take all this data. If we didn't have the science of aging and the AI, we'd be nowhere. We wouldn't be talking about this today. I wouldn't have written a book.
Yeah. Well, it's important for people not familiar with the term of health span. That's basically not just lifespan, but how long you can be healthy.
Yeah, I don't think we really want to get to some age and be demented or compromised. What we're talking about is if you don't have heart disease, cancer, or neurodegenerative, you're pretty darn intact. You may have some achy joints and other matters, but those are the things that really interrupt end our health span.
Maybe let's turn to another aspect of it, which is the chronic disease aspect.
Yeah.
I mean, when we're talking about chronic disease, we're talking typically about diabetes, heart disease, cancer. How do we start to make an impact in that? I don't know if you want to pick one, if you want to start with cancer.
I think we can make a huge impact in cancer because we have just simple polygenic risk scores for all the common cancers. That's like one layer of data to say you're at higher risk. And we have multi-cancer early detection tests that can pick up microscopic cancer. Why people would get a total body MRI when you could find microscopic cancer, not a mass on an MRI, which may or may not be cancer. So we have some tools for cancer. But the one thing that I think is unanticipated is the GLP-1 drugs. The Ozempic, Zepbound world.
Yes.
It's the most momentous drug class in medical history. And we've only seen part of the story so far. In the book, I write about how it took 20 years to figure out that it wasn't just about diabetes, which is amazing. What if we had a AI today and said, should we test this for obesity? Because the developers, Novo Nordisk and later Lilly, of these drugs, they only saw 3 or 4 pounds that people with type 2 diabetes would lose with these drugs. And this woman in Norway, scientist Lotte Knudsen, she kept pushing, we got to try it in obesity. And they wouldn't listen to her because, well, she said, diabetics are not losing weight. They finally did it, and everyone knows the story, 20, 30, 50, 80 pounds of weight loss. Now, when you lose that much weight, for people who are obese, you reduce the risk of cancer, you reduce the risk of heart disease, and neurodegenerative disease. It wouldn't be surprising to me that now with pills that are remarkably effective to substitute for injections that can be much less expensively, that a large proportion of the population would be taking one of these drugs or even their successors, that is, those that are even more potent and potentially with less side effects. So we have a drug class now added to lifestyle factors we didn't have before.
Right.
As you know, they are in big trials for preventing Alzheimer's in people who are not overweight.
Yes.
We're going to be doing a long COVID trial in people who are not overweight. The effects are really quite extraordinary. The ability to crack obesity, we would have been happy just to do that. But all the other things that are coming from it, who would have thought that you could prevent addiction?
Yeah, that's remarkable. Yeah.
So some of the secrets of the gut-brain axis, which is tied into the immune system and it's tied into the science of aging, this is what's given us this newfound potential to change. We don't have to only rely on drugs, but there's this, as we discussed, this kind of interdependence.
Well, and I think having lifestyle infrastructure with these drugs, that combination is particularly interesting because you can make sure that you can lose weight while keeping muscle. And also, hopefully, patients can go off the drugs, at least for some periods of time, and not rebound.
We don't have encouraging data at the moment because at least half of people gain weight back when they stop.
Yeah.
And that's not good. But I do think that we'll come up with the ways to hopefully not rely on such a long-term commitment. The results on muscle mass, that we'd been very worried about that. And I think when people combine taking the drugs with strength training, and we do know there's muscle mass loss just with weight alone, but that it looks encouraging, even though the companies have been acquiring muscle-making drugs.
Yes.
That may not prove to be particularly necessary.
And so what else would you put into the chronic bucket? I think one of the things that you've written about is AI plus all the things you can track.
Yeah, I think the ability to look at the organ clocks, which was initially reported here at Stanford by Tony Corey and his colleagues, and now validated and replicated by multiple groups. The fact that we can do that and have the brain, the heart, the immune system, and other vital organs, and we can say, this one organ of yours is 5 years out of pace with your real age. Then we can integrate that with these other layers of data. Oh, if that's the case, what about your polygenic risk score? Is there anything pointing to that disease or organ? We can look at your whole body aging, epigenetic, Horvath clock. We can also look at specific proteins, like, for example, for the brain, p-tau 217. And what's amazing about that protein, which we can get now, and it's not that expensive, but that in itself gives us over a 20-year warning about mild cognitive impairment. It's modifiable by exercise and lifestyle. We've seen people in studies that drop more than 50%, even up to 80%.
It's intriguing that it's not binary too, so you can track the gradient.
Exactly.
And that would get particularly scary if it's increasing.
So we're talking about in people without symptoms but are at high risk, having this access. I don't recommend any of these things that we're talking about until you know you have an increased risk. But once you do, then you can say, I can do something about it and change the course of what otherwise would be that person's natural history. But the molecular clocks, this collection of proteins, this is something else that's striking. The O-link and SomaLogic, they're between 6,000 and 11,000 plasma proteins. What we've learned from them, the fact that there's 3 bursts of aging during our life is not just a linear story, and the fact that we're learning about the underpinnings of diseases, but most importantly, we have these organ clocks that are inexpensive to get. When you start having genes and proteins and these other layers of data, that's when you find out what is making us unique and what we are at risk for during our extended time.
And therefore what we should do to change it and improve.
Yeah.
There are a lot of enemies of the future, and maybe a nicer way to put it is that people could be skeptical.
Yeah.
And they're used to operating a certain way, and they have a certain belief that this isn't going to work or for whatever reason. What would you tell them, like to your fellow clinical colleagues, to try to change their mindset from a sick care mindset to a preventive mindset?
Yeah. I mean, to me, it's all about compelling data.
Yeah.
So for example, the Alzheimer's drugs, which don't really work and they're very risky, but the reason they were bought into by the FDA ultimately was because the amyloid came out on the scans, right? And there was a little bit of cognitive score improvement. But here we have things that are, metrics that are extraordinary to help us as a bridge for compelling evidence. Ultimately, you want to say we prevented these diseases in people that had definition of their risk and then active surveillance, preventive, pull out all the stops.
Right.
Like, for example, speaking about waste, we do mass screening for cancer. We treat everyone as the same based on their age. And that's the only criterion for screening, age. We only pick up 14% of cancers from that mass screening, which costs over hundreds of billions of dollars a year. Right. Now, what about only 88% of women will never have breast cancer? Why do 100% of women have to go through this?
And especially with Bayes' rule, you could actually use priors that you could measure.
And we don't do it.
Yeah.
And this is a corollary of what we're talking about. Why don't we take the risk profile and say, you know what, to a woman or for a person having colonoscopy, you don't really ever have to have it, or you can have this, once in your lifetime or twice, whatever. We don't treat people as human beings with particular aspects that we can define today.
Why is that?
We're ingrained in stupidity. I mean, maybe when these mass screening programs started, that was the best we could do.
Yeah.
But we've known about polygenic risk scores, and we learn now about all these other ways to assess risk. And then with added on the AI part of it, we have to do better. But, just having the screening part cleaned up would save a tremendous amount of money.
So let's maybe shift gears to talking about the future. So what do you think, let's assume things work out well.
Yeah.
That people,
I hope so.
And what is the best case scenario that you think is plausible? Like, what's the science that's coming on the horizon? Let's say we all decide to make this shift towards prevention and chronic. What do you think we will get for it in our next 5 to 10 years?
Well, I think we'll start to see that people are eventually getting to much older ages than we are now without these three major diseases. I think that's a gradual thing. It's not like we're going to see a light switch here, but that's what will be the trend. And we will see countries that will implement it because they don't have the obstacles that we have. We'll see much less of that, and the shift, bending this curve to the people that are older and healthier gradually. We're not talking about curing. We're talking about preventing. It's a lot better than curing, but it takes time to see the benefit.